I just want to talk about graphing logs a little bit, and there's some other stuff in this chapter like properties of logs, but I kind of looked it over and I don't think we really need to do it. If we do, we can always fill it in later. But as far as graphing logs, I can't remember if we talked about it last year. Start with just the graph of an exponential function, like that. Well, you should know what that graph basically looks like. Y-intercept, if I plug in 0 for x, 10 to the 0 power is 1. And it's just 10 to the x power is just going to be an increase in exponential. It's going to look something like that. Well, now if I said find the inverse of that and graph it, remember to find inverse, you flip x and y. Now I got to solve for y. Well, if I'm trying to solve for y and it's the exponent, I need to log. So I'd have log, and it's going to be this number to this power, so it's going to be 10 to the y power equals x. Remember, if you just write log and there's nothing there, it's implied that it's a 10. So the inverse of this guy right here is just y equals log of x. And I think I told you exponentials and logs are inverses of each other. Well, so the graph of that, you can imagine, inverses reflect over that line. So if I have the point 0, 1 in this graph, I'm going to have the point 1, 0 here, and this is just going to be like this. And that's how all just basic log graphs look. So anytime you have y equals log of something, or even y equals ln of x, it just looks like that. Remember, ln is log base e, and e is just a number, 2.71 something, something, something. So they all look about the same, and if we just graph it real quick here, like y equals ln of x, yeah, there it is. Your calculator's not good at showing that it runs down along the y-axis there, and that there's an asymptote on your graphing calculator. It looks like it hits it, but of course it doesn't. And of course, all of our shifting stuff works on these too. So you have to do a couple of these where you graph like y equals 2 times the ln of 3 minus x minus 4. The number in front, the 2, is just going to make it increase faster. The negative 4 is going to shift it down 4. Inside here, that's kind of weird to think about. 3 minus x. It's the same as negative x plus 3, which the 3 is going to shift it right or left. I don't know, it's kind of weird. Because of the negative x is going to flip it over the y-axis. So then the whole 3 thing, it's not worth thinking about. But we know regular looks like that. That's terrible. Ours is going to be flipped over the y-axis and shift down, and it's going to be something like that. As long as you know that going into it. If you can just imagine it's going to be something like that going into it, it makes this a lot easier. So then, to graph it, I always start, is there a y-intercept? Well, think about domain here. Can I plug in any number for x and get an answer for y? I think so. I don't know what's going to stop me. Right? That's not true. Never mind. I can't have a negative number in my parentheses, because if I do, you can't. Remember, got to back up here a little bit. Let's say we have log of, just basically log of x. Okay. Remember, this means 10 to what power gives me x? Well, so I can't have log of negative 10. 10 to what power gives me negative 10? There's nothing. You can't do that. You can't take a positive number, raise it to a power, and get a negative result. Even if the power is negative, remember that just flips it. It doesn't make the result turn negative. So back up here, this would be like log base e of something. Oops, I can't have negative inside of here. So when I'm thinking about domain, 3 minus what? The biggest number x could possibly be would be 3. 3 minus 3 is 0. when x gets above 3, I'd have 3 minus 4. That'd be negative 1. I can't have that. So just by thinking about it, figured out our domain, everything is probably going to be an asymptote right here, and everything will be to the left of that. So going back, y-intercept, remember, plug in 0 for x. So 2 ln of 3 minus 4, just use your calculator for that. This does have a gray circle on it. These problems where you have to graph, I forget where it is. It's up here. But you could still just use your calculator to calculate that. But just don't graph it. So I go 2 ln of 3 minus 4. Oops. Wrong thing. There we go. 2 ln of 3. Oh, no, I'm not graphing. There's a baby crying in the background has distracted me. I was thinking about something else. Negative 1.8. So there's my y-intercept. Negative 1.8. And I know it's going to come down like this and go up like that. Remember, because we were thinking about it earlier. At this point, you can plug in some more points. Oops, that was my... I'm an idiot. I'm all flustered here. What did I just do? Plugged in 0 for x, solve for y. That's my y-intercept, negative 1.8. There we go. If I want my x-intercept, I can go ahead and find that. Same thing. Now just plug in 0 for y. 0 equals 2 ln of 3 minus x minus 4. I'll add 4. Divide by 2. I get 2 equals the ln of 3 minus x. And now when you're solving for x and it's in the parentheses like this, I know we did a bunch of these last year. You got to switch it back to exponential form. Remember, ln means log base e, so this is e squared. That's a terrible e. Paper moved. E squared, e to that power will equal 3 minus x. So then solving for x, stupid paper keeps moving. I'll subtract 3. So I got e squared minus 3 equals negative x. And then divide by negative 1. So I'll just take whatever that answer is and make it negative. And here we'll go e squared. Make sure you close the parenthesis. Don't put minus 3 in there because that's the power. This is e to the, so if I go 2 minus 3 like that, that would be e to the negative 1 power. That's not what I want. I want e squared minus 3. There's my answer. And then remember I divided by negative 1, so I'm going to make that negative. It's negative 4.39. And that was my x-intercept. Oh, he's really mad up there. Something like that. You could plug in a few more points, and I think last year on quizzes when I had you graph logs, I made you get 1 extra point just to make it a little more accurate. But we know that basically it's going to look something like that, and that's good. Oh, that's ugly right there, that little, whatever though. Good enough. Just kind of getting the whole picture down, the big idea in your mind, thinking about domain and range. Well, not really range, but thinking about domain, and then calculating your x and y intercepts and getting a good picture is all you gotta do on those. And you gotta graph a few. And other than that, the others are kind of review, just stuff about inverses, exponentials, little y equals ab to the x stuff. Yeah, and like I said, everything else we can fill in down the road if we need to. So that'll be it for this section. Here's that. Notice I got the quick review ones on there. A bit of composition of functions on the quick reviews and finding points of intersection. Pay close attention on those. 7 through 10 on the quick review. 7 and 8. Don't use a calculator. Find the point of intersection of those. 9 and 10, you can use your calculator and use the graph. I guess I should show you on the calculator. To find the intersection point of two curves, let's see, I'll just do like e to the x, oops, wrong button, yeah, and y equals x, so I better go, yeah, that's good enough. Now I was going to say, those aren't going to intersect. Let me change that. X plus 6. There we go. Now they'll intersect. Actually, they'll intersect twice. Remember, that doesn't stop right there. So these two curves intersect here and here. To calculate those, it's kind of like calculating the zeros. You use second, calc, intersect. Go down to intersect. You'll see first curve. All it's saying, this little cursor, you can have more than 2 curves on here. You can have a whole bunch. If you only graph 2, this is really easy. You just hit enter twice because it's asking for the first curve, and your cursor's on the first one. And it doesn't matter where along it is. It's just saying which one is the first one. You hit enter. Goes to the other one. Second curve. It's just that one. This is just for if you have more than 2 on there. You have to pick the 2 you want to know where they intersect. So hit enter again. Guess. That's just like my intercept. I'm going to move the little cursor somewhere over there. Close enough. Hit it. Boom. There's my intersection. If I want the other one, just do it again. Calc intersect. First curve, second curve. I just hit enter twice. My guess though, I don't want that one up there. I already found that one. So I'm going to move that thing down here. Hit enter and hopefully, boom. There. Gives me that one. Oops. There we go. So that's how you use your calculator to do that. Oops, back to that if you weren't done. Like I said, the rest are just inverses, review stuff. I wrote due Wednesday, figure give you tomorrow to finish it. I will, if all goes well, I will be back Wednesday, finally. I know I've said that like 3 times, but this is the truth. And we'll figure everything out from there. And then we'll get to the good stuff right here. Ask Jeanette, it's fun. Alright, that's it. See you Wednesday.